So I want to start with a bit of a confession. I don't know if any of you have considered submitting to this conference for next year. I think it would be great if you did. One of the things we see is that the strength of this conference is how many different industries are presenting, how many different kinds of stories we're hearing, and it's the stories of our peers that make it really compelling. If you do submit, you'll probably see a nice little article from Jean explaining, what to do in order to get your paper accepted, because they do get quite a few papers. And one of the things it says is, if you're a vendor or a consultant, well, sorry about that, you will almost certainly be rejected. And another thing it says is, these types of submissions are almost always rejected. And one of those is why culture is important for DevOps. So you've already seen the title of this talk is Culture is Important for DevOps. And the second confession is that I am a consultant. And it's actually worse than that, because not only am I a consultant, I'm also a vendor. I work for IBM. We have a stand out there. We have some lovely tools that we would like to sell you. I'm not involved in the development of those tools. I'm not going to try and sell them here. But I think because I'm a consultant, one of the things I see is a range of practices across different companies. And it's a bit like the DevOps confessions that we saw on Tuesday. There's a whole bunch of things that companies do, that we all do, that we don't really want to get up on stage and say that we do, because they're a bit embarrassing and we know they're really not right. And they're not the sort of embarrassing that you can turn into a lessons learned that's a really positive thing. They're just the sort of embarrassing that you really hope nobody knows about. So instead of DevOps confessions, this is a little bit more like DevOps accusations, where I see lots of different companies and I see the things that they do. And the effect, really, of these things is a failure at DevOps. So hopefully, all of you will be sat in the audience and you'll be thinking, well, I've never seen that in any company I've worked for, and I would never do that, and my teams would never do that, and who does that? So if you're thinking that, then the bad news is that this presentation might be slightly less interesting for you, but the good news is that you're in a really good place, so you can leave feeling happy. So one of the things that I often see when I visit a client, I should say as well, why am I visiting clients? I'm Holly Cummins. I work for the IBM Garage, and our mission is to help customers adopt the cloud, adopt DevOps, adopt Lean, adopt design thinking in order to really do a transformation. So very relevant for what a lot of us are doing here. And I visit a client and I get introduced to the DevOps team. I think, okay, DevOps team, not everybody chooses to have a DevOps team, but there are reasons for that model. But then the next thing is, well, yes, this is our DevOps team. And last year we called them the build team. So we have this DevOps transformation, but it's a very shallow transformation. And what's really happening is we're doing the same things that we've always done, but we're attaching new labels to them. So that's not really going to help as much as we hope it will. And ultimately, I think what we see with the new labels is we also see importing new technologies. And I think there's this sort of desperate hope in the industry that if I adopt containers, I'm going to get DevOps, right? Well, it doesn't quite work like that. So then you think, oh, no, okay, yeah, I know. Containers aren't going to magically make me DevOps. But Kubernetes will magically make me DevOps, right? Well, no, even Kubernetes, as popular as it is, isn't going to make everything okay with Kubernetes or with DevOps. So we had a conversation with a bank out in Asia Pacific recently, and they came to us and they said, IBM Garage, we really need you to help us. We have some really serious problems. We can see that we're going way too slowly now, and we've got all this COBOL estate, and we'd really like you to help us rewrite this COBOL estate and turn it into microservices. Okay, that might be the right thing to do. But then there was this little qualifier. which is that the release board only meets twice a year. So at this point, it's not the COBOL that's the problem. It's not the lack of microservices that's the problem. It's the fact that the release board only meets twice a year. And we see this all of the time, where I think we sometimes have a natural tendency to focus on one thing and not notice the other things that are also getting in our way. So if you want to look at the 8 DevOps trends to be aware of in 2019, one of the top trends is microservices. And so what this little article from Hacker Noon says about microservices is microservices are independent entities and hence doesn't create any dependencies and break other systems when something goes wrong. So at this point, you all should be laughing, right? Because anybody who's ever done it in microservices or managed a microservices system knows that this is the theory. And the gap between theory and reality can sometimes be pretty large. So I visited a client, and they were doing microservices, and they said, every time we change code, something breaks. Which is, of course, the exact opposite of what you're supposed to get with microservices, right? With microservices, the dream is one thing can break and everything else is completely resilient. Whereas, in fact, they had a situation where one thing made a change that was quite innocent and correct, and yet everything else still completely broke. And the reason, of course, was that they had a distributed monolith. They had replaced their intercomponent communication with HTTP. But they hadn't actually decoupled it in any more meaningful way. So they had a distributed monolith, but without the benefit of compile time checking, which I think hopefully it should be obvious that this is worse than just a non-distributed monolith. And so ultimately, just because a system runs across 6 containers, that doesn't mean it's decoupled. Decoupling is something else. It's not just about how you lay it out in space. So does anybody, speaking of space, does anybody know what this is from my very bad drawing? No. Okay, so this is the Mars Climate Explorer. And I should say as well, most of these are client stories. NASA was not a client of mine, so this is other people's trenches, but still a bad trench. So this is what the Climate Explorer looks like when it's not badly drawn. And you can see there's some interesting things about it. I don't know if you can see from where you are, but there's something that looks very much like a dryer tube holding parts of it together. And then at the front, it seems to be made of a bin liner. And the bin liner seems to be held onto the rest of it with sellotape. And it had a very sad end. And I don't think it was the bin liner and sellotape that was the problem, because I think NASA probably know what they're doing in terms of the physical construction of these things. But what happened with the Mars Climate Explorer was that it crashed into Mars, which is not what it was supposed to do. It was supposed to go around Mars. And why? Well, what happened? Well, it had two systems. One was the system on the Explorer itself, and another one was a control system on the ground. And the problem was that the Mars Explorer itself used metrics units, and I think you can see what's coming. The unit on the ground used imperial units. And for the measurements that they were doing, the units were close enough that it wasn't like an order of magnitude out. They were about a factor of 2 out. And so then with the calculations, you couldn't spot by eye that there was a problem. But it meant every time they tried to steer the Mars Explorer, they ended up steering it to somewhere that wasn't where they intended. So this is a case where having a distributed system did not help. We had 2 independent teams developing it. They didn't communicate appropriately about what their expectations were. And the result was that the Mars Explorer was lost. So really, with microservices, you've got to have consumer-driven contract tests. You've got to have some way of making sure that everybody has a shared understanding of what's supposed to be happening, and that if that understanding is violated, that gets picked up as soon as possible in the development cycle. It doesn't wait till the end. So I'm going to tell you another space story. So this is the cluster, which was a rather inappropriate name given what happened, and the Ariane rockets. And this was one of the most expensive space losses in history because it was a 370 million loss. They tried to send the rocket up into space, and it did not go up into space. Instead, it sort of flew up a little bit and then exploded, and that was the end of the rocket. So what had happened? How did this even happen? Well, they'd done something quite sensible, which is that they'd reused the software from a previous version. And they sort of tested it, but they'd stubbed out one component. And the one component they stubbed out was that component that they reused. And so there were some assumptions that had been baked into that other component that were no longer true. And of course, so the one component that broke was the one component that was stubbed out when they tested it. So even though they'd done a lot of testing, they ended up with this catastrophically expensive loss. And we see the same thing, actually, with the Mars Climate Explorer, where at the end, they did a detailed investigation of what happened, and they said, oh, well, yeah, had we done end-to-end testing, we believe this error would have been caught, which is one of those things that you sort of look at and you think, oh, why didn't you think that end-to-end testing was a good idea before you sent it up into space? But, it's easy to miss things out. They add cost, they add complexity. So really, as well, this should be obvious, but microservices, so the first thing that you have is your contract tests, which are a shift left to catch the problems early. Then the next thing you have, which is your fail-safe, is that integration test. Another thing I hear all the time is, we have a CI/CD. Well, these tools are great, but CI and CD, it's something you do. It's not something you buy. And particularly, I see this sort of gap. So we have this system, which is the CI/CD system, but then I hear things like, I'll merge my branch into our CI next week, which is another way of saying, I'll merge my branch into our continuous integration system next week. And I hear things like, continuous integration, continuous deployment, continuous delivery. We release every 6 months, continuous integration. And I'm sort of thinking, we keep talking about continuous, but I don't think that word means what you think it means. Because if you're only integrating once a week, and if you're only releasing every 6 months, that's a really strange definition of continuous. And of course, we do have to be pragmatic with all this. So if you had, when we talk about how often, developers should be pushing to master, what we're really saying is how often should they be integrating? And we're talking about continuous integration. But if we were to be really strictly correct on continuous integration, that would be every character. And obviously that's not a bad idea. It is technically continuous, but it's a really stupid way to develop software. It would cause chaos. Probably a much more reasonable thing to do is to say, well, we should be committing several times an hour, and we push every commit. Another thing you could do is, okay, well, we say we commit several times an hour, but we don't push every commit because we want to get them to build up to a decent set of functionality, so let's push several times a day. And then you can carry on down the spectrum. So once a day, once a week, okay, fine, once a month. When I first joined IBM, which I should clarify, this was 20 years ago, so this isn't a recent thing. But I joined the team, and the team told me how they delivered software. And we had this build call. I was working on WebSphere, and we had a build call that was a worldwide call. It happened every day of the week, including Saturdays, and you did not want to be on the build call. You did not want to get focus on the build call. And so people had worked out that the most effective way of ensuring that you were never, drawn onto the build call was to not break the build. And the most effective way of not breaking the build was to never deliver software. So they pushed every 6 months in order to avoid that build focus. And this, again, is one of those things where the incentive that you thought you were creating wasn't the incentive that you were actually creating. We thought, oh, yes, we're going to really ensure we have quality by making sure no one breaks the build. And instead, it was we ensured no one did any work. So, in terms of where on the spectrum is okay, well, it's going to depend. It's going to depend on lots of things, the complexity of the team, the size of the team, the complexity of the software. But I really would advocate for trunk-based development, and the cutoff line for trunk-based development is once a day. So if it's not going at least once a day into master rather than into a branch, you're not doing trunk-based development, and you could be doing a lot better. So, okay on that side, bad on the other side. Very bad. And then, really? So, the next question is, how often should you release? And again, in that CI/CD language, what we're really talking about is how often should you deploy? And again, there's a spectrum. So where we were with WebSphere was once every 2 years. Many companies now, they're managing to be releasing to the public every push, which is several times a day. That's amazing. It's really hard to get there. You need some good engineering techniques. So, to get that, you've got to have your feature flags, you've got to have lots of safeguards like that. I would say that if you're deploying once a sprint, that's okay. If you're deploying once every 2 years, then you're seriously old school. If it's once a quarter, well then, there are reasons to do this. Again, in one of the talks I was in earlier, they were talking about how they had the technical capability to deploy more often, but their customers didn't have the capability to absorb their releases more often. And that's something that we've seen as well, is that customers don't necessarily have the appetite to consume releases depending on what's going on with the release. So every epic, that's good. I'd say getting something deployed out to the public, every user story, that's the sort of the sweet spot. And then if you're doing it every push, then you're pretty hardcore in terms of your engineering practices. And so then the last one on that CI/CD spectrum is how often should you test in staging? And what we really mean by this is how often are you delivering? So there, I think really, your test system and your pipelines should be supporting a test on every push. So that's sort of easy, and there's sort of no spectrum there. In fact, it is a little bit more complicated than that as well, because you're probably going to have a range of testing. Some of it's going to be really quick. Some of it is going to be your big hardcore suites that involve the performance test and that involve the load test, and they take 3 hours to run. Well, if you do that every push, you're going to start to get some economic problems and some time problems. So actually, even there probably is a range of do the lightweight tests every push, do the slightly more involved tests less often. But of course, as I said, that's the sort of the ideal, but what I often hear is very far off the ideal. And so one of the common conversations that I have is one which starts, we've implemented all this functionality, but we can't actually release it. Well, why? It's there, it's value that is sitting on the shelf, and you're not going to actually get that value until you get it out to someone. So why can't we release it? What are the barriers that are stopping more frequent deploys? And again, often there are genuine barriers. Microservices, again, going back to the distributed monolith, we see microservices where an individual microservice gets into a really good shape, but we say, well, oh, no, we don't release just one microservice, even though that's the whole point of microservices. We release all our microservices at the same time so that we can do a proper testing to make sure that they all work together, because we don't actually know if they all work together because we don't have the contract tests. Well, okay, so rewind, get the contract tests in place, make sure that our microservices are actually independent, and then we can start to get some of that value from the microservices. Another thing we see is the sort of the Wizard of Oz scenario, where it looks beautiful. It looks like it's complete. There is a UI that developers have been working on for months. And when you click on stuff, there's maybe a 50-50 chance whether it's actually going to work. I think everybody's really familiar now with these ideas of user stories and vertical stories. So you have your front end, you have your integration layer, you have your back end, and a single user story should encompass all of those. But I think what we're still catching up with a bit is what order do we do that in? So what I see a lot, there's a single user story has all that, but what I see a lot is that the front end is done first. And there's good reasons why people do this, which is that the front end is the most gratifying bit. And what we see as well is that this is rewarded by the business, and this is rewarded by management. So that's something that, as leaders, you can be really keeping an eye on. We were working on a large project recently, and some teams were from the IBM Garage, some teams were from external consultants. And our team, they did a ton of work, a ton of back-end work, a ton of integration work to make sure that when they delivered their story, it would actually work. One of the other teams just wrote the front end. And then at the playback, they showed this beautiful front end. And everybody went, wow, you're so effective. You've been working really hard. This looks amazing. I'm really pleased. And so the team that was rewarded, and they actually got an award for it, was the team that had written the empty front end. But of course, that empty front end, the effect of that sitting in the code base was that nothing else could be released, because they had this liability of code that if a user saw that front end and tried to click on something, they would have been angered, they would have raised defects, and so it meant that having this there wired in stopped anybody else from releasing. So instead, we really need to be rewarding and encouraging the secret work. Start with the back end, then go up to the integration layer, then go up to the front end. And so by the time anybody sees it, it works. And again, this is something that developers need to be doing, but it's also something that as a management team, we need to be making sure that we don't reward these empty front ends. So do vertical slices for sure. I don't know if there's a good name for that practice. So I tried back out development, but that made it sound like all of the changes were getting reverted, which isn't really the intention. So I tried back first development, and that wasn't really any better. So I don't know. But another thing to do is that deferred wiring. So code's really safe to have in the code base, and it can be going out if it's not actually wired into anything. And again, feature flags. Feature flags, I think, are a bit more scary than the deferred wiring. We do see a lot of postmortems of incidents, and it comes back to, well, we had all this new functionality, and we had it guarded with a feature flag, and what we'd missed is that we hadn't guarded one bit with a feature flag, or there was a side effect that somehow we hadn't quite caught, and so this code went out, protected by a feature flag, and caused a problem. So that one, there is, I think, again, a sort of a gap sometimes between theory and practice on that. Another thing we see is we can't ship until every feature is complete. Well, why? And again, I think a lot of this has to do with what we expect from our users. Our users won't find it compelling enough if we release now. And sometimes that's totally true, right? Like if it's hello world, users aren't going to be delighted. But there is a point beyond which you shouldn't be continuing to develop without getting feedback. So that, there's the quote from Reid Hoffman, of LinkedIn, that if you're not embarrassed by your first release, it was too late. And a lot of this, again, comes back down to these lean methodologies of trying to strip out everything that's not going to give you the business feedback that you need. And some of that stuff feels really important, so it can be quite painful to strip it out. But again, all of this, we have this sort of fear that if we release and it's not perfect, well, then that's it. We only have one chance to get it right. And sometimes that is totally true, right? So for the Ariadne, it failed in 36 seconds. So they didn't really have an opportunity to be, monitoring their dashboards and seeing, oh, it's in the process of exploding. If we push a change now, we might be able to stop it. It was too fast. And you can't A/B test a rocket when it's that expensive. But I think a lot of us, we think we're there on that spectrum, and we think, I've got one chance to get it right. But actually, there is a spectrum. So the Ariadne was a catastrophic failure. They really, really only had one chance. For other things, there are going to be bad things that happen if it goes out and it's not good enough. There is going to be brand damage, and people are going to say, oh, well, that's crappy. I'm not going to try it again, even after the improvements come. Or, it could just be that your brand isn't damaged, but people stay away, and so you may as well not have bothered releasing because everybody goes, not using that. But, I think we often can be having a conversation with our consumers and a conversation with our stakeholders where we say, yeah, what do you think of this? And here's our roadmap. Let's talk about our roadmap. You can see that we're getting better all the time. You can see that there's a new cadence of features coming out, which means that the thing that wasn't quite good enough there, try again in a week and it's going to be better. That's pretty cool. And then finally, of course, you can have this A/B testing where you release it and it's absolutely awful. But it's okay because it goes to such a small portion of your user base that it's safe. And 2% of your users think your new functionality is terrible, but the other 98% don't care. So there's no bad consequences. So really what we need to be trying to do is questioning our assumption that we're all writing Ariadnes, and instead trying to get up to the point where we can be doing the A/B testing, where we can be doing that more incremental delivery of value. So going back to another thing that stops releases, I think, is process. So with the Mars Explorer, one of the really sad things about it was that they couldn't see the Explorer. So, we talk all the time about feedback. DevOps is all about feedback. And one of the reasons that they had problems was that the geometry of planets means that the Mars Explorer was sometimes behind Mars, sometimes the controller was on the wrong side of Earth, and so they could only communicate every few days, so they had to be sort of doing these adjustments based on a few days. And if they had more frequent feedback, it would have been okay. But even with that feedback every few days, there was an interesting thing. which is that the navigation team actually spotted a problem. And we put in place these change control processes to protect us from risk. But what happened with the Mars Explorer was that their change control process actually created risk. So the navigation team spotted a problem, and they said, it keeps happening that I think it's going to end up there, and it's like over there. What's going on? So they reported the problem, but they didn't use the correct process, and so nothing was done. And we see this all the time where we have these processes that are supposed to protect us, and they don't. We had a situation, a customer satisfaction situation, where one of our clients came back to us and they said, well, this provisioning software you've sold me, it's supposed to do cloud provisioning, but it's broken. So I thought, that's odd. I'm pretty sure it works. So the IBM team investigated, and what it was supposed to do was to allow them to spin up, cloud instances in 10 minutes. Amazing. But what the customer was seeing was that it was still taking them 3 months to provision their instance. So when we investigated, it turned out that they had an 84-step pre-approval process. So the technology was working fine, but all of the processes around it meant that the technology couldn't do what it was supposed to do. I don't know if any of you were in Rasmus's Maersk talk earlier this week, but he had a really similar story, that they put in place all this really cool provisioning, and they managed to get their lead time down from 100 days to 85 days. So it was almost the same, even with all the technology in place, because it's these other things. And we see similar things where we'll go to an architecture review board, and the software is shipped, it's out in the field. We validated the architecture because it's out in the field and it's working, but we still have to do this process, which isn't adding any value. So for all of these processes, we really need to be looking and saying, is this actually adding value? So again, with the Explorer, the navigators warned something was wrong, but there was a form and they didn't fill in the form, so nothing was done, which is just, Another thing we see often is that someone will say, well, I'd like to ship, but I can't ship until I have more confidence in the quality. But of course, it's not easy to fix, but this is so fixable. Because usually what's causing this is something going on with the testing. So often I'll be introduced to the test team. And I'll meet the test team. It's like, hello, test team, very nice to see you. And then there's sort of this thing, and the test team test everything manually because our test team don't actually have any skills in automated testing. And there completely is a place for a test team. Exploratory testing will find things that tests written by the people who produce the code will not find. But in order to not be a barrier to release, these things need to be automated. Otherwise, what we get is bugs escaping to the field. So when I hear our tests aren't automated, what I actually hear is, yeah, we don't know if our code currently works. It worked a while ago, the last time we did the manual testing, but who knows what's going on now? And that's a really scary place to be, and we don't want to be there. And then another thing that we see that prevents the release is, well, I'd like to release, but it costs too much to release. And again, this is something that we should fix. Part of the point of DevOps is that every release should be incredibly boring. So if we see lots of cost in the release, keep releasing until we drive that cost out with automation. Keep releasing until it's cheap. Another thing I see, and this feels like a really low-level sort of development level thing, but I don't think it is that there'll be a build, and someone will break the build. And they won't know, because the only way that they can see if the build is broken is by going to a separate web page that has the Jenkins on it and looking. And they're doing other things, right? They're writing code. So then there's someone who checks that web page and goes, the build's broken, and then goes and nags them. And this is incredibly inefficient. And it also shows something about priorities. So if, as a leader, you walk around and you don't see the build status really where everybody can see it, that says we kind of care about whether our code is passing or not, but we only sort of care. And getting that build status up really prominently with something physical like a traffic light. Lean has this idea of an obeya, and it's a room where you have all of your project metrics and you can just go there and it's there because it's that important. And this is sort of taking that same idea but putting it out through the space to say, this is really important, so we're not going to rely on someone to pull that metric, we're going to make sure it's on the wall for them. And of course, on a complex project, probably can't be just one light, it's going to be a more complex radiator, but you want to get it into the physical spaces. Another thing we see is centralized control. So people don't feel ownership of the build because only Bob can change Jenkins. Another thing we see, and this is something that external people are really good at spotting, is the broken Windows. So I come in and I say, oh, the build's broken. And they say, yeah, it's been broken for a few weeks. I'm like, didn't anybody care to fix it? Well, no. So I'm sort of aware, I mentioned DevOps accusations at the beginning, and I'm aware that this does come across a bit as, you did this wrong, and you did this wrong, and they did this wrong. And of course, it's not that easy, right? Like, we all can get into bad places in well-intentioned ways. And one of my colleagues, she has this idea of modern DevOps, which is, when you're cloud native and, you've started on the cloud and it's really easy to do DevOps properly. But then as well, many of us are doing heritage DevOps, where we have a lot of stuff already and we're trying to figure out how to do the best we can with this stuff. And so I'll go for about 30 seconds more, because one of the things that we hear a lot as well, which fills us with delight, as you can imagine, is you'll be coding on the mainframe. And it's like, oh, that's fun, because trying to do DevOps on the mainframe, it's sort of this dinosaurs on roller skates situation where you can maybe make it work, but it's going to be really hard. And it's really tiring as well. There's a lot more technological resistance and cultural resistance when you're in that situation. And so then what we see with a lot of DevOps transformations, and we've seen this over the 3 days, is that we have a bit of a failure of transformation endurance. We have really good intentions, and then it becomes so hard, and so then we just sort of give up and then maybe try again in a few years. And I think that having that idea of not just doing the transformation now, but keeping going with the transformation is key. And with all of it, the remembering the why, and not focusing on the technology, not focusing on just a few things, but thinking, okay, well, what was I trying to achieve? I was trying to achieve that business agility. Am I actually getting that? If not, let's try something else. So I'll leave that there. I will be hanging around, happy to have conversations, questions, all that kind of thing. And thank you very much.